my channel. It's a reactive. In this video we see the three-phase circuit, but especially in three-phase star and delta connection. So let us see. First, just we have to understand what is the phase sequence. In a three-phase system, there are the voltage having the magnitude and the frequency that is displaced by the 120 electrical degree, and phasors are attaining their positive maximum in particular order sequence like R, Y and B. This is the sequence. So one sequence is R, Y, B and another sequence that is the R, B and Y. This order is called the phase sequence. Okay, suppose especially if we talk about the any circuit or any phase and the voltage across that VAB and the current through that IAB from this point A to B, but if you want to write in the reverse direction, then you can write VAB equal to minus VBA, and same for the current IAB equal to minus IBA. So what is the mathematical for this VAB? That is the VA minus VB. So just if you want to write VB minus VA, so the minus notification results the VAB equal to minus VBA. Okay, so that is both is equal. So the interconnection of three phase, there are the two possible way of the interconnecting the three phase of the system. One is the star connection and the second one is the delta connection. Star connection already known as the Y connection, and the delta connection say the mass connection. So the phase voltage and line voltage is there in the star and delta connection. So what is the phase voltage? The voltage across the each winding. This is the winding. Okay, so the voltage across the each winding is called the phase voltage. And what is the line voltage? Voltage across the two line is called line voltage. Suppose the line R and line Y is there, so the between line R and between line Y, that is the line voltage. And what is the phase voltage? So that is across the only one winding, that is known as the phase voltage. Let us see. Here is the star connection or the Y connection. This three phase R, Y, B is like this, and the neutral is between this three phase. One point is sorted of this all three coil, and that is the neutral. Okay, so this is the line R, this is the line Y and this is the line B. So what is the line current? This is the line current IR, this is the line current IY and this is the line current IB. Okay, here is the voltage across this phase only, that is the phase voltage. Suppose if you want to say what is the phase voltage of R, that is the ERN. Okay, and what is the line voltage between line R and between line R and Y, that is the VRY. Okay, you can also say that it is the ERY. Okay, you can write E or V. Okay, so between line Y and between line B, that is the VYB, and for the first to last, that is the VBR. So what is VRY? VRY equal to the VR minus VY. And what is the VBR? That is the VB minus the VR. And what is the VYB? That is the VY minus VB. Okay, so you can directly say these both are must be different. Okay, and this current, this line current and this phase current, both are same. Okay, let us see the mathematical. This is the funda for this phase current and the voltage, and I already explained all these things. Okay, so here is the relation. What is the VRY? But just we have to see the phasor diagram first, then after I already explained. Okay, So here is the phase ERN. Suppose if you not want to write the neutral, then you can say this is the R phase. Okay, so voltage of R phase. Here is the Y phase voltage, and the last one, this is the B phase voltage. Okay, if you not want to write neutral, then it is the phase voltage, already phase voltage. If you not want to write, then you can. Okay, so this is the R phase, this is the Y phase, and this is the B. Sorry, okay, this is the B phase voltage, not this. Okay, so the R phase and Y phase 120 degree aparted, and the Y phase and B phase is also the 120 degree aparted. Okay, so suppose this is the R phase having the positive magnitude, so the same magnitude in the reverse direction, this is the minus R phase voltage. Okay, so this is the minus E phase for the R phase. Okay, and this is for the minus EY this side. Okay, this is positive, that's why this is in reverse direction, that is the negative. So here for the same for B, where is the B? Yeah, it's here. So this is for the minus E phase, but minus EB. If all phases are symmetrical, so you can write directly minus E phase here, minus E phase here, minus E phase here, if all phases are symmetrical and having the same amplitude, but each having the different amplitude, so you have to mention the name in minus EY, minus EB, sorry, minus ER and minus EB. Okay, so here the mathematical expression. So this is the VRY. Let us see here, VRY. So VRY, what is the VRY? That is the resultant of ER plus minus EY. Here is the minus EY. Here is the minus EY. That is the addition of these two. That is the VRY. Here already expressed. This is the phasor difference. Okay. Similarly, for another two phase, VYB, that is the VY plus minus VB, and for VBR, this is the EB and minus ER. Okay, so VBR means VB minus VR. Let us see the delta connection. What is in delta connection? So in case of star, the current of phase current and line current both are same, but the voltage, phase voltage and the line voltage, that are different. So this is the reverse than the star. Here the phase voltage and the line voltage, suppose just we talk about R and Y, so here is the R phase voltage, and that is equivalent as the ERY, okay, or the VRY. That is same for the all three phase. The phase voltage and the line voltage are same, but the phase current and line current are different. Suppose if we take this direction of current, so here is the IRY, okay, means IR minus IY. Okay, so this is the incoming current from here. Okay, it's IY, and outgoing current, that is the IR. Okay, so you can write directly by the KCL. Okay, and this is the phase voltage between the R and B, between the Y and B, and between the R and Y. Delta connection or the mesh connection, let us see what is. This is the phase current, this is the line voltage, this is the line current. Now let us see the phasor diagram. Here is the VRY, or you can directly write the VR. Okay, so no, you cannot directly write VRY. Okay, but this is also the phase across these voltage, because the phase voltage and line voltage are same. So the current IR 5 degree aparted from the same phase due to the inductive load. Okay, and the IRY, the IYB 120 aparted, and the IBR also 120 degree aparted. Okay, now from the IRY and minus IBR, you will find the resultant IR. Okay, Understand or not? So this is the IR, this is the IY, and this is the IB. Now the power in the three-phase system, when the load is balanced, the phase and the phase current in the balanced three-phase circuit may be written like this. This is for the R phase, this is for the Y phase, and this is for, mistake is here, this is for the B phase. Okay, and the same mistake is here, this is for the B phase. Okay, where what is the phi? This is the phase angle between the phase voltage and the phase current. What is the E phase? That is the phase voltage in RMS value. RMS value is there, that's why root 2 is here. And what is the phase current? That is the I phase, that is also the RMS value. So what is the total instantaneous power? P equal to the voltage of that phase and current through that phase. So the mathematical form is there. So if you want to write the resultant and make it open and simplify, you can find like this. Okay, sum of this 3-second harmonic oscillation CHM 2 omega t, which we have the average value of 0. Omega is there and the whole cycle integration of these 3 is 0. Okay, therefore the average power, so the all the system, phi is there only, this is 0, phi is there, this is 0, phi is there, this is 0. So this is the cos phi plus cos phi plus cos phi. So the 3 cos phi. So the resultant power in three-phase system, this is the instantaneous power, 3 E phase I phase cos phi. If you want to put, instead of phase voltage and phase current, if you want to write the line voltage and line current, so for the star connection, what happening, let us see in the next. Okay, in the star connection, just you can write the line voltage like this, and the line current is same as the phase current. So instead of the power, just you have to put, instead of phase voltage, just here is the line voltage. So what is the net power? This is the root 3 VL IL cos phi. And in case of the delta connection, here is the apparent power. So apparent power S is like this. Okay, S equal to root 3 VL IL. Cos phi is not there. And in case of, okay, this is the Q. Okay, here is the cos phi, that is the active power, and for the Q, that is the sin phi, and this is the apparent power, that is in kVA. You already know that, so no need to explain. Q equal to root 3 VL IL sin phi, cos phi is comes out, and the Q equal to P into tan phi. Okay, power in three-phase delta connection. Now in the delta connection, the VL equal to V phase, current is different, IL equal to root 3 I phase, and just we put down the value of this phase to line value. Here is the VL and here is the IL divided by root 3. So the resultant is same, that is the root 3 VL IL cos phi. So in case of star connection and delta connection, in both circuit, the power is same, that is the root 3 VL IL cos phi. Let us see the apparent power, that is the same as the star. So the same function is there. So that is the apparent power root 3 VL IL, and for the reactive power, that is the sin phi. So you can see here. Okay, so Q equal to P tan phi. So thank you very much. This is up to now.